Hi everyone, I'm Matt and welcome back to 10-Minute Story, although fair warning, today's story might stretch the 10-minute rule just a bit, because we're talking about one of the most powerful and consequential inventions in human history, the nuclear bomb. One weapon, one flash, one moment that can change the world forever. A scientific breakthrough, a moral dilemma, a symbol of both security and fear. Nuclear bombs have shaped the course of the 20th century and continue to influence global politics today. But what are they really? How do they work? Why were they created? And most importantly, how do they still affect our lives now? In this video, we'll explore how nuclear bombs work, from physics to explosion, the dramatic story of the Manhattan Project, the devastation of Hiroshima and Nagasaki, the Cold War arms race, and the modern nuclear landscape, the science of radiation, fallout and nuclear winter, and of course the ethics, politics, and future of nuclear technology. There's a lot to unpack, but we'll do it together, clearly and responsibly. Let's begin at the atomic core of it all. To understand nuclear bombs, we need to understand one of nature's most powerful forces, nuclear fission. Imagine an atom, not the kind in your high school textbook, but a uranium-235 or plutonium-239 atom. These are big, unstable atoms. When hit by a stray neutron, their nucleus splits apart. And that one split releases a massive amount of energy. Yes, this is Einstein's E equals mc squared in action. A few more neutrons, intense heat and deadly radiation. Now multiply that by millions, all happening in a split second. That's a chain reaction. And if you can control the geometry and timing, that becomes a bomb. To do that, you need what's called a critical mass, enough fissile material packed tightly so the chain reaction sustains itself and explodes outward. But that's not easy. Engineers needed clever ways to bring subcritical pieces together instantly, or the chain reaction would fizzle out. Two key bomb designs emerged: gun type, which was used in Little Boy over Hiroshima, where one uranium piece was fired into another like a bullet, and implosion type, which was used in Fat Man over Nagasaki, where a plutonium core was squeezed rapidly by high explosives. These designs worked too well. Later we'd go even further, combining fission and fusion in thermonuclear bombs, unleashing energy comparable to the sun itself. But let's not jump ahead just yet. We've cracked the atom. Now comes the part where science becomes history. It all began with fear. In 1938, two German scientists, Otto Hahn and Fritz Strassmann, discovered nuclear fission. The possibility of a Nazi atomic bomb terrified many, including Albert Einstein, who co-signed a letter to President Franklin Roosevelt in 1939. That letter kick-started the Manhattan Project, a top-secret multi-billion-dollar effort to build an atomic bomb before Germany could. The scale was immense, 130,000 people, many unaware of the real purpose. Dozens of hidden facilities across the United States. Leading scientists like Robert Oppenheimer, Enrico Fermi, Niels Bohr, Richard Feynman, and more. And there was military oversight by General Leslie Groves. So, three main sites led the effort. Oak Ridge, Tennessee was all about uranium enrichment, Hanford, Washington handled plutonium production, and Los Alamos, New Mexico focused on bomb design and assembly. They were all working against time, secrecy, and honestly a lot of moral uncertainty. On July 16, 1945, the very first bomb was tested in the New Mexico desert. This was the Trinity test. Witnesses described the explosion as brighter than 1,000 suns. And the shockwave actually shattered windows 100 miles away. Some scientists celebrated, but others, like Oppenheimer, quoted the Bhagavad Gita, "Now I am become death, the destroyer of worlds." If you're finding this story as mind-blowing as the science behind it, take a second to support the channel. Like this video if you're learning something new. Comment below what part of this shocked you the most, the speed, the scale, or the secrecy. And of course, subscribe for more stories that connect history and science. Let's now witness the moment that changed the world forever. August 6, 1945, 8:15 in the morning, Hiroshima, Japan. The sky was clear. A lone bomber, the Enola Gay, flew over the city. Then, from its belly, it dropped the bomb codenamed Little Boy. 43 seconds later, a bright flash lit the sky. 80,000 people died instantly. Buildings were vaporized, shadows were burned into walls, fires swept through miles. 3 days later, on August 9th, the United States dropped Fat Man over Nagasaki, killing another 40,000 people on impact. But the suffering didn't stop with the blast. Thousands more died from radiation sickness in the following weeks. Survivors, Hibakusha, endured burns, cancers, stigma, and psychological trauma for decades. By August 15th, Japan surrendered. World War II was over, but a new era had begun. Photos of Hiroshima's flattened landscape and burned victims became symbols of unimaginable human tragedy. The atomic bomb was no longer just a scientific milestone, it was a moral catastrophe. And honestly, it wouldn't be the last time the world faced that threat. After the war, the United States wasn't the only nuclear power for long. In 1949, the Soviet Union tested its first bomb. What followed was a nuclear arms race that, frankly, reshaped global politics. Both sides built thousands of warheads, then tens of thousands, and then hydrogen bombs, 1,000 times more powerful than the ones used in Japan. So, this all led to the doctrine of mutually assured destruction, or MAD. The idea was simple, but terrifying. If one side launched a nuclear attack, the other would immediately retaliate. And the result? Well, it would be global annihilation, plain and simple. Let's talk about some key moments. The Cuban Missile Crisis in 1962, when the United States and the USSR came honestly just minutes away from nuclear war. And from the 1950s through the 1980s, bomb tests literally shook the earth, from the Pacific to Siberia. Meanwhile, duck and cover drills in American schools tried to prepare children for something that honestly no drill could ever stop. By the late 1980s, there were over 70,000 nuclear weapons in existence. That's enough to destroy humanity dozens of times over. Thankfully, treaties like START, INF, and NPT did help reduce those arsenals. But the bombs didn't just disappear, they simply became fewer and honestly more powerful. A nuclear bomb doesn't just kill with fire and force, it leaves behind an invisible enemy radiation. When a bomb explodes, it ejects radioactive particles into the atmosphere, called fallout. This settles into soil, water, and food. The long-term effects? Cancer, especially leukemia and thyroid cancer, genetic mutations and birth defects, and contaminated environments for decades. Think of Chernobyl, though not a bomb, to imagine the environmental damage. But the scariest possibility is nuclear winter. Here's the theory. If multiple nuclear bombs are detonated, they create massive firestorms. These fires send smoke and soot into the upper atmosphere, blocking sunlight for months. What follows? Global temperature drops, crops fail, and starvation spreads. Even a limited nuclear war, say between India and Pakistan, could kill billions through famine. Nukes are not just about explosions, they're about ecological collapse. This is where science meets philosophy. Some argue that nuclear weapons have kept peace, that countries avoid war because of the risk. And yet, we've come dangerously close to nuclear war by accident. False alarms, computer errors, and misinterpretations of radar signals. The world's fate sometimes rests on the judgment of one person in a control room. And then there's nuclear terrorism. A single bomb in the wrong hands, not launched by a state but carried by a group, could destroy a city. Efforts like the Non-Proliferation Treaty or NPT try to limit spread, but enforcement is honestly pretty tricky. Nations like India, Pakistan, Israel, and North Korea developed nuclear weapons outside of it. In 2017, the International Campaign to Abolish Nuclear Weapons, or ICAN, won the Nobel Peace Prize pushing for a full ban, like we've done with chemical weapons. So the question remains, can we trust ourselves with a weapon this powerful? Nuclear technology is evolving. New developments include tactical nukes. These are smaller yield, meant for battlefield use, and they really raise fears they might actually be used. Hypersonic missiles, just way too fast to intercept, giving nations less time to decide, and submarine-based nukes, hidden under oceans, ready to launch in just minutes. Meanwhile, fusion research, like ITER in Europe, aims to harness nuclear energy for clean power, not bombs. It's the same reaction that powers the sun, controlled and peaceful, hopefully. But as long as nuclear weapons exist, policies really need to keep up with technology. This isn't just for scientists or generals, it's for all of us. It's easy to feel powerless when the stakes are global. But you know, your voice actually matters. You can support arms control and transparency. Vote for leaders who prioritize diplomacy over escalation. Share knowledge and stay informed. Join organizations or campaigns working for nuclear disarmament. Remember, weapons are built by governments, but controlled by societies. From splitting an atom to splitting cities in half, nuclear bombs have forever altered what it means to be human. We created something we can never uninvent. But honestly, we can choose how we live with it. Will we continue down the path of fear and escalation, or will we use our knowledge and compassion to build a safer future? This is the conclusion of our story. Thanks for watching 10-Minute Story. If this episode challenged or inspired you, please go ahead and comment with your thoughts and subscribe for more stories that matter. Every day, a new pill of curiosity. See you next time.